All right, so here we go. This is the second to the last. Oh, there's a weird box and you can't see the screen. Well, no, that's just really weird. Okay, so let me know even if there's still that weird box on there. I wonder if it is. I wonder if it's the poll. Nope, because it looks like people can see the poll. All right, can you see the poll? I guess that's the other question. All right, let me know if you still see some weird stuff. Yeah, are you ready to earn a 5? Yeah, it should say that. And so it does say, are you ready to earn a 5? And then underneath there is a poll and you'll have to answer. Absolutely, yes, you bet. Is this AP Lit? And it looks like some people have already answered, but the ends are cut off. Oh, that's really weird. So here, let me stop sharing and I'll start sharing again. Let's try it again. So we'll try it again here and see if it comes up right. Do 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 do. All right. So tell me about now. Can you see everything? So if I do this, does that help? Thanks for helping me. So does this help? You're able to see everything now? Do 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 do. So here we go. Nope. How about now? Can you see everything now? No? Oh, the poll is still cut off. Ah. All right, so let me try it one more time here. That's really weird because we've not had this issue before. So let's try it better, but the poll options are cut off. Okay. Better. All right, so we'll try it one more time. So let's try it one more time. Well, we'll try it 2 more times. So let's try this one. Now, is that any better? It is weird. I agree, it is weird. Glad we got on early. Any better? Well, since we're taking a look at the poll, let's just go ahead and finish the poll. Maybe that'll help it. So absolutely 2 votes. We have 6 votes for, or 5 votes for yes. You bet is 18% or 2 votes. And then some people are trying to figure out if this is AP Lit. So we'll get rid of that. And from what I see, it looks like you should be able to kind of see what we're doing. Let's check in. We'll just check the Pear Deck and kind of see what's going on there. So I did put the link to the Pear Deck inside of the chat. So let's do that. It's just the good. Okay. Yeah, I don't know why the poll's all messed up. Oh, well. Something to know. All right, cool. So here we go. Let's go and get started since we have lots to do. This is on QQT. Remember, QQT is Qualitative Quantitative Translation. And paragraph length response is just what you see there. It's paragraph length response. However, you do not have to write a paragraph for that to come out well. In fact, if you, well, we'll talk about it here in just a second. Heads up. We are recording the screen and it might appear on the website, YouTube, or other public channels. If you ask a question, your name might appear on the screen or be read aloud. So please change your name if you don't really want it to be read in order to avoid this. So we've got a little presentation here from our founder and CEO. This is, here we go. Let's check it out. Oh, I don't hear it. You know what? Let's stop for just a second and let's see if we can get this sound to come up. She's going to talk a little bit about paying for the
giving away $100 to pay for your AP exams to like 50 different students. How do you win? Easy. You just got to post about the AP experience on social media, on TikTok, Instagram, or Twitter. Use the hashtags YesWeCram, and with Fiveable and tag at Think Fiveable. So one person will win every single day, and this is how you can win. It is going to be a group of students who actually judge the winner. They will pick the winners, and this is how they're going to choose. It has to capture the AP experience. Do they look at that post and think like, that's 100% what this feels like? Is it creative? You know, is it funny? Does it have a really awesome song in it or really good use of some sort of meme, anything? Do we see creativity and engagement? How many likes do you have? That literally is going to help you win. The more likes, the more likely you are to win. And then finally, does it incorporate Fiveable? Is it in the caption, what you're wearing, in something that you're doing? How have you incorporated Fiveable into it? So this is how you can win. A couple of quick notes. Make sure you follow Think Fiveable so that we can DM you if you've won. You can post as many times as you want. You can post today, tomorrow, every day, as many times during the day as you want, but you can only win once, so keep that in mind. And finally, some of our best social interns came from this contest last year. So if you're really awesome at social media and you're looking for an internship, show us what you've got because we want to hire you. So I can't wait to see your posts. See you on the flip side. Good luck on your exams. Talk to you later.
All right. Hey, guys, tell me, is the screen any better? I did something different. So let me know if it's any better. Hopefully it is. It's just really strange that it's weird. So we'll give it a second here since there's a little delay anyway. Yeah, good. Thank you, Kayla, for letting me know that it is better. All right, May the 4th. It's the big cram session. So if you like Star Wars, May the 4th be with you, and we will study. We will do that for several hours. So hopefully I see you there, and we will just cram everything we can into your head. All right, here we go. Tonight, we're going to talk about what kinds of things are in a QQT. And the biggest issue is using graphs. And relationships. We're going to practice a little bit. And we're going to look at paragraph length responses. We're going to use BCD/A. And we're going to practice. Okay, cool beans. So here we go. Let's go ahead and take a look at this. So on this slide, you can kind of go through and take a look. You'll notice that you'll be able to circle some things on the slide if you don't mind. And so one of the things I'd like for you to do is if you can, never mind, you can't circle, but what you can do is if you can list 3 qualitative features of the rocket. So this is a SpaceX. This is comparing the Falcon 9 and the Falcon Heavy, 2 really cool, very cool rockets. And then they have the new one, Starship. Starship is going to take us to the moon, and NASA has said that they'll do that. So really kind of a cool thing. So if you like physics and you like rockets, you maybe one day will work for SpaceX, or maybe you will work for, I don't know, you could work for NASA, I guess, if you wanted to. But tell me some things that you see in this that are qualitative. All right, we've got some good responses here. So I'm going to put some of these responses up so that we can see kind of what you're saying. Here we go. So here's a few responses. Country of origin, that is definitely qualitative. Function, manufacturer. So that's really awesome stuff. So anything that doesn't really deal with numbers. Give me 3 quantitative features. 3 quantitative features. Quantitative features. That's what we're looking for. I think more people will know this. You guys are doing awesome. Fantastic. Brianna, are you able to read the screen? Is it looking okay to you? For some reason, we're having trouble with the webcast tonight. I wonder if it's maybe just people don't have very good connections. Yeah, looking good. Got a lot of excellent responses here. Okay, so if everything looks good to you, then we are set. All right, I love it. Check out some of these answers that you folks have given. Looking at some good things here. Some people have given us some numbers. Other people have talked about what is quantitative on there. So you could do it either way. Definitely height, diameter, width. Even gave all the numbers. Diameter 70, 3.66, and 12.2. Width 3.66 diameter. So excellent job. That's what we want to know. So remember, anything with numbers is quantitative. Anything with no numbers is qualitative. So what kinds of things will you need to do on a QQT, or qualitative, quantitative translation? You will work with what we call multiple representations. So when you do these questions, you are going to notice you'll feel like you're answering the same question over and over and over again. For example, it might say, you have a car, it moves 5 kilometers down the road, and it takes 30 seconds to do that. What is the speed of the car? And you would then answer that question. And then the next thing would say, how do you know that that is the speed? So you would have to type a sentence or two explaining how you know it's a speed. Then they would give you a graph of position versus time, and they'd say, based upon the graph, what is the speed? Prove how you know. And you would have to go through, find the slope of that graph, and then explain how you found the slope. Then there might be a motion diagram, or they might ask you to draw a motion diagram. They might have a free body diagram. They'll look for representations of things like energy and momentum. They might use bar charts. They might use circle graphs. They might use all kinds of things there. They'll work with diagrams and pictures, such they might have pictures of like a wave for the energy of a spring, and other things like that. So those are the things that you really have to be able to do, is be able to interpret graphs, motion diagrams, free body diagrams, look at tables, come up with information. So you really will feel like you're answering the same thing over and over again. These are worth 12 points. They take 23 minutes is what they advise you to do. So you want to try to stay within that time limit. Other things you might need to do in a qualitative, quantitative translation, they might give you some situation and ask you to make a prediction about what is going to happen, and then give a words-only explanation of how you arrived at your prediction. So one of the things my students did today was we did a QQT, and they had them predict what the impulse was. And so they had to explain how would they do that. They also had to go through and look at a prediction. So there were 2 students. One made a prediction talking about what that impulse was, and the other one also made a prediction, but one of them did it correctly by looking at the area under a force time graph, and the other one did the slope. And so they had to explain why the person that was wrong did not have it correct. Big issue for a lot of students is deriving equations. So make sure that you know how to start with conservation of energy. For example, you might have something that is on top of a hill, and then it goes down to the bottom of the hill, and they will ask you to derive an equation for the speed at the bottom of the hill. So you have to make sure that you show every single last step. I read a lot of these exams over the summer. So we work for the College Board, and we go through and we do what's called the reading. And we have a lot of students that just put down the answer. We can't give them any credit, even though the answer is correct, because they didn't do exactly what it says here, and that is derive. Another thing that they'll ask you to possibly do is evaluate an equation for reasonableness or plausibility. And really all you want to do there is just look for relationships. Don't worry about how big the equation is or what weird things they put into it. You're really looking for just 2 letters, one on the left, one on the right. And you want to see, what is the relationship? Is it a direct relationship? When one goes up, the other one goes up? Or is it inverse? When one goes up, the other one goes down. So be really careful with those. So let's take a look at this graph. This is a linear graph. The equation, remember, for a line is y is equal to mx plus b. So we're only going to talk about and think about just y is equal to mx. We're going to make our y-intercept or our b value 0 for most of these. If you're given the equation f is equal to ma, now they might give it to you this way, they might give it to you a different way, but we're going to use f equals ma. We want to know what letter goes on the y-axis in what units. And by that, what I mean is when you look at f is equal to ma and you compare it to y is equal to mx, which one of the three letters would you put on the y-axis? And once you know, go ahead and put it on the y-axis. So it can be f, it could be m, or it could be a. Once you put f, m, or a on the y-axis, also include the correct unit for force. So be very careful that you do that. Then what I'd like for you to do is tell me what goes on the x-axis, and you can write f, m, or a. Remember, we're basing it on this. And then I want to know what are your units. So what are your x units? So once you put down a letter, then you need to put down what the units are next to it. And then on the line, I want you to put down which of these things represents your slope. Which one of these things represents your slope? So I'm starting to see people do that, and it looks awesome. So you guys are doing a very, very nice job. And don't forget to write on the line itself, what the slope represents. So it's either force, mass, or acceleration. We're just going to use the letters and then use the I want you to use the letters and then use the units. So in parentheses, go ahead and put the units there. And we're doing awesome so far, so it looks really good. Job, Nikki. Nice job. Excellent, Caroline. Good. Good job, Victoria. Beautiful. Alicia, very good. And I will tell you there are two answers for this. So there's a couple of different ways that you can do it. And so some people are probably going to do it one way and other people are going to do it the other way, and that's absolutely fine. I see both of those, and so we'll put both of the correct answers up. So hopefully that will super duper help. You folks are doing fantastic. I love it. There is a typing tool there, so if you want to put, ooh, very nice, Spandan. I like it. Beautiful job. Okay, cool. Thanks for putting the extra word there on your graph. Very nice. All right, I'm seeing a lot of great answers here, folks. We're going to take a look at some of your answers. You might notice that I will post something. I'll probably then all of a sudden start talking about it. There's a little bit of a delay here, so you'll get used to it as we go. So I'll try to pause just for a little bit before I start talking about what I switched the slide to. So you're going to see some answers, and then just a little bit later, you're going to start hearing me talk about them. So here we go. This is going to be the first one. This one is almost correct. It is super close to being correct. You'll notice that they do have the correct thing on the y-axis, force in newtons. They have the correct thing on the x-axis, acceleration in meters per second squared. They have the right label, but they do not have the right unit. Remember, mass should be measured in something slightly different. So just be really careful with your units, but really great job. We just have to change the unit on this one. I'm going to scroll down to the next one. So again, we have force and we have acceleration. So that's really good. This one, force, acceleration, then we have mass again. And now you will notice that you could put mass on the x-axis and acceleration on the slope. that is also appropriate because we really don't know which one of the two letters is our slope and which one is our x-axis. I really didn't ask you to stick to y is equal to mx. You could have y is equal to x times m. It's the same thing. So if you did that, then you might have mass, just like this person does, on the x-axis, and then we have the slope as acceleration. Very good. Awesome job. Here's another one, has everything correct. So this is super important to be able to do. You've got to understand when you look at a graph quantitatively and qualitatively what everything means. So fantastic job. Good job, folks. All right, let's go ahead and go to, so for these, I will also put a example of what this should kind of look like. And so I don't have kilograms for my unit for mass on here, which is fine. All right, so there is the there's the solution. So now let's do this. We were given the equation F equals ma, and what I did is I've put force on the y-axis. I did put acceleration on the x-axis. I know that mass is my slope. This is the general mathematical or mathematic equation. And it says y is equal to 15x. So I know the slope of this line is 15. And this is my math equation. Here's what I'm going to have you do. I want you to replace the y with the word that represents what's on the y-axis. So instead of y, you're going to put force. So go ahead and type force and then type the equal sign. You're going to then type 15 because that is your slope for your mass. And then give me the unit for mass. So to repeat, again, what we'll do is instead of y, you're going to type force equals, and then I want you to type 15, but you have to have a unit after the 15. So whatever the unit for mass is. And then after that, you're going to put times and then whatever the label is on the x-axis. And for our x-axis, that is acceleration. So your equation here is going to be F, or force, is equal to 15 kilograms, or you could put a Newton divided by a meter per second squared. That is also a kilogram. It works out that way, believe it or not. And then you'll put times and then acceleration. So I'm starting to see some people do that, and you're doing a fantastic job. So I'm going to just star some of these so I can show you what people are doing. Beautiful job. You guys are doing great. The reason I'm having you doing this is if you do this on the AP exam, when you get a graph, then you can answer any question they throw at you. But you have to recognize what this slope and what the letters on each axis really mean. And so please make sure you do that. Here are some of the great answers that you folks are giving us. Force is equal to 15 kilograms times acceleration. So notice that's just F equals ma. But now we have a quantitative aspect with it. We have an actual number. So if I wanted you to, I could have you solve. If I said your acceleration is 10, you could tell me immediately what that force is. You'd say it's 150. If I told you that your force was 1,500, you could tell me then what your acceleration is, because now you can actually see what's going on. So these are all really great answers. Love this. You guys are doing fantastic. So let's practice one. Here's the next one. Oh, here's our answer. And by the way, I want to show you a lot of times you're not going to recognize what the unit is for your slope. And so that might confuse you a little bit. If you come up with something like this and it doesn't make sense, like a Newton per meter per second squared, then go through and any unit that's not a base unit, so if it's not a kilogram meter or second, try to make it into that kilogram meter and or second. So I know in Newton is a kilogram times a meter per second squared. So a Newton divided by a meter per second squared is a kilogram times a meter per second squared divided by a meter per second squared. So now I can cross off the meters per second squared, and I'm left with a kilogram. So if you're not sure what something stands for, so you see this and you do not have a base unit, this is a derived unit. This is one that has base units that make it up, and I know what those are. Do that, figure out what you can cross off, and see what you're left with. Then you go, oh, that's just mass. So most of the time, you should be able to do that. All right, here we go. Let's take a look at the next one. This one is change in position is equal to 1/2 AT squared. So this is the second kinematic equation on your AP Physics 1 equation sheet. But you'll notice we are missing the original velocity. And we're saying that because our original velocity is 0. So I'm going to go to Google. I'm going to pull up Google, and I'm going to type in AP Physics 1 equation sheet. If you do that and hit enter and click on the first link, you will see the equation sheet. And we're going to blow it up really big so we can see the equations here. And then I'm going to move it down, and you'll notice that here are my first 3 equations. And so when we look at the second equation, this one is the change in position. So I can move the XO to the other side to say X minus XO is equal to that original speed times time plus 1/2 AT squared. So here's my change in Y. So that is my delta, that's my Y in mx plus b. Here is my m, here's my x, and then plus VOT is my plus b. So if you didn't catch that, that's okay. Just know we're going to use this equation, and I want to do the same thing we just did that we did with F equals MA. I'd like for you to put down what goes on the y-axis based on our equation here. What could you put on the x-axis? And then what could you put here on the slope? So it looks like I've got some of you that have done this already, and that is fantastic. Looks really good. And we're getting some things down, so that looks really awesome. Very nice job. So very good. So we're thinking about what goes on the x-axis down here, what goes on the y-axis, and then what part of this equation would be our slope. So doing a fantastic job. Seeing some really good answers here. I'm going to select some of the answers. Remember, we won't see your name, but we will see what you've put, which is fantastic. Good. And there's a lot of answers for this one that you could put. So there are a lot of answers for this one, and that is perfectly fine. I love what some of you are doing. You're really mixing it up and make it look really good here. So I love what you're doing. All right, let's take a look at what some people did. And for this first one, this person put delta X, or the displacement. So that's perfect. That is measured in meters. Very good. Then they put time squared here on the x-axis. And we want to be careful. This seconds needs to be squared also. So the only thing that this one needs to have changed is if you do this, you'll want to put, if you square the label, you have to square the unit too. So this would be time squared, and that would be in seconds squared. So we want to make sure to put a square on that. I love what they did here. This is only 1/2 of the acceleration. So if they get the number 5, thank you for fixing that. That's awesome. If you got the number 5 here, that's only half the acceleration. I would have to multiply it times 2 in order to get the real acceleration. So good job. This one, this person did t squared, and they went ahead and they multiplied both sides by 2. So they have 2 times delta x, and then that gives us just the acceleration here. So if you want to avoid having to multiply by 2, notice that that's what we did here. We have to multiply by 2 to get it. On this one, we would not have to. So excellent job. Here's another really good answer. We've got the x, we have the t squared, second squared, and then we have the slope again as 1/2 of the acceleration in meters per second squared. So just some awesome answers. Looks like you're doing a fantastic job. So I'm so happy you're getting this. This person actually put the half in front of the t squared, which you can also do. So either a 2 in front of the x, a half here, or a half on your slope. So any of those would be appropriate. Here is my answer that I had. And now what we're going to do is I want you to write a physics equation using the general mathematical equation, y is equal to 16x. So when you do this, here's our y value, here's what we put on the x-axis, and we know our slope is half the acceleration. I want to see what you do for your physics equation. There is a trick to this one. And so we'll see how many of you get the trick. It's looking good. We'll give you a little Jeopardy theme song here. All right, beautiful. Okay, so now we've done that. Let's go through, kind of see what you folks are doing. We know that 16, so let's think about this. 16 is my slope. That's only half of the acceleration. If 16 is only half my acceleration, then when we go through and do this, we don't want to divide this by 16. We actually want to multiply it times, we don't want to divide by 2, we want to multiply by 2. So for this one, we really should have 32. But if you put 32, we don't need the half anymore. So we'll want to get rid of the half. So our answer for this one really should be exactly what this person has done. Delta x is equal to 32 meters per second squared times the time squared. So that would be the correct answer. That's a tough one. Remember, our slope is only 1/2 of the acceleration. So if our value is 16 and I say 1/2 of a is equal to 16, the only way to get a by itself is to multiply both sides by 2. So that's the reasoning for why we have to do what we do. And that kind of talks about it down here. This is probably one of the most common things that we see students miss on the AP Physics 1 exam is when they have a slope and we know that it's half of something, you have to multiply by 2 to get the true value. So be careful with that. All right, one more for you to do. I have the equation for kinetic energy. So I want to know what letter goes on the y-axis and what units do I use. What letter are you going to put on the x-axis and what units? And then what letter is the slope? We'll give you just a little bit of time here to answer. All right, seeing a lot of good answers. Beautiful. You guys are doing fantastic. Hopefully you're getting excited. You're going to get this test out of the way. You will be all done. All right, let's take a look at some answers. And so we're going to look at just a few answers here. And so we've got an answer. We do have K on the y-axis, but don't forget your units. So units are super important on our graphs. Delta V squared, which is great, but we need a unit for that one, and then half of M. So let's take a look at the next one. This one has units on it. So we do have kinetic energy in joules. We have delta V squared. Be careful, because if you square delta V, we want to square both the meters and the seconds. Otherwise, this becomes acceleration. And this is perfect. 1/2 of the mass in kilograms. So good, good, good. Let's take a look at what the correct answer should be. So there we go. Do notice that you have to square both the meters and the seconds. All right, so I gave you another mathematical equation. So y is equal to 64x. I think this is the last one we're going to do like this. And go ahead and type your physics equation. Be really careful when you do this one. Yeah, if you did the slope for this, you'd have to do v squared. Because your slope would be v squared. But then when you did your number, you know that that represents, so yes, Pops, you would have to do that. But they won't do that to you. The most they'll do is they'll do the half. All right, you guys have this one much better. Excellent job. So here's a really good answer here. We do have, oops. So let's check out this one answer I've got. Yeah, good job. So kinetic energy is equal to 128 kilograms times our velocity squared. And that is what you should have. Notice that the unit here is, you could put a joule per meter squared per second squared, but that really is just mass. So you could also put just kilograms. Either one of those would be 100% correct, and you would get full credit for that. Let's talk a little bit about paragraph length response with the remaining time that we have. I like to have my students, instead of using claim, evidence, and reasoning, I like to have them use BCD/A. So it's kind of like ABCD, but instead we're going to start with B. One of the things that we notice when you folks write your answers is sometimes you tell us some great things. You tell us the answer, you explain it, but you don't use enough physics, or you don't use the basic physics that makes the problem work. So for example, when you do this, you'll want to state a principle of physics, a law of physics, or a physics equation. So you might say a principle of physics would be conservation of energy. You might talk about a law of physics. You might talk about a physics equation, F equals ma. But when you do that, you also need to tell us what that means. So here we've talked about velocity is distance over time, or distance is velocity times time, or time is equal to distance over velocity. You can write it out, or you can give us an equation in words. So if you do a physical principle, you might say time and speed are inversely proportional, or going faster results in less time of travel. Stating important definitions also counts. So if you say if an object has more mass, then it's more difficult to make the object reach a certain speed, or an impatient person wants things to take less time. So those are basic physics or basic principles or basic equations. Really looking for you to explain the basics of the explanation that you're going to give. You also need to make sure that you cite specifics of the situation they give you. So if they give you a graph, talk about the graph. If they give you a bar chart, talk about the bar chart. If they give you a picture of somebody running, talk about that picture. Sometimes they want you to compare two cases. So they might say before and after. So before the collision and after the collision, then make sure you compare and contrast those. So citing evidence means you're looking at whatever they give you, whether it's a graph or a picture or a diagram, and you use that diagram to give evidence that you understand that basic physics. The last thing you can do is draw it together. So once you set out your basic physics, show how the two come together. The basic physics and the specifics of your situation or your evidence, show how those come together. But don't forget, you really need to make sure that you answer the question, okay? Some free response items give you an answer, or they tell you what will happen in the situation, and you just have to explain it. That way you can just use BCD. Or they may have you check an answer, and then you can just use BCD. So we're going to practice this a little bit. They always will say in a clear, coherent paragraph length response, and then they'll give you the word explain, and then they'll ask you about it. You can do bullet points on this. You do not need to do a paragraph with a thesis statement and all that. Some of the best ones I've seen people put CER, claim, evidence, and reasoning, or they'll do basic physics. So they'll do B, C for cite evidence, and then D/A for draw it together and answer the question. So what I'd like for you to do is, what is the basic physics that would tell us why the spheres reach the ground at the same time, even though they travel a different distance? So this one travels a shorter distance than this one. So what basic physics principle, law, or equation would help us understand that the time to reach the ground would be the same? So if you can just give us the basic physics, so that means a basic principle of physics, a law of physics, or an equation. Any of those things would be 100% appropriate. I'm hoping I see all kinds of different things here, and so far I am. So I'm seeing some good things here. And remember, we're just looking for the basic physics. Excellent job. Very, very good. And it can be short. It does not have to be super lengthy. And you do not have to write in a complete sentences. You just need bullet points. All right, this looks awesome. So let's take a look at what some of you said for this one. So somebody said forces of gravity, or the force of gravity on each ball. Very good. Somebody else said the acceleration of gravity is negative 9.8 and it's constant. Then they explained a little bit more, which is absolutely fine. Here, when objects are in free fall, gravity is the only force acting on them, and gravity is a constant. That's perfect basic physics. That's awesome. So I'm seeing a lot of this talking about gravity. The way I did it was I just said in projectile motion with no air resistance, the time for a projectile to fall is the same, regardless of whether or not the projectile is motion in the x direction. You could do that. You could talk about energy. Energy is conserved as things fall. You could talk about what a lot of you did, and that is the only thing acting on the two objects is the force of gravity. Any of those answers would be perfect. So for the next one, let's cite some evidence. So if you said there's gravity there, what do you see in the picture that's going to link gravity, the picture, and an answer together? So sometimes this is hard to do. Sometimes it's easy. It just kind of depends. So if you said gravity, what in the picture tells you you're going to use gravity to help you find the time that they fall. I love it. You guys doing a great job. Excellent. Alicia, that's very nice. Yeah, perfect. There's a key letter that is in this diagram that I think if you see that letter, you will be 100% on it. And I'm seeing that a whole bunch from you folks. Beautiful job. Excellent. Lots of great answers here. Beautiful, beautiful. I love it. Excellent. So I'm going to show you some responses. I know we're going really quick tonight, but I want to make sure that we get through these. Then when we're done, I'll make sure everybody has a copy of this. We'll put a link so that you can get a copy. And then anything we don't go through, you'll be able to see the answers to. For evidence here, a lot of you have said that both spheres are dropped from the same height. And now what we can do is, because in the last part we said gravity was the only force acting on both balls, that will help us then come to a conclusion that they have the same time. So I'm looking at these, just seeing some beautiful things where you're talking about the change in y values are the same. So this person started with an equation and then started to talk about the y values being the same. Another one, height. So now we're talking about gravitational potential energy. Here's another one. They both start at the same height. So this is an awesome way to do it. Both spheres start at the same height. So that's what we see inside of the problem that helps us with this. So excellent job. In mine, the evidence I gave, I talked about the equation here a little bit, but it's really the height that's the important thing. Okay, draw it together. This will be the last part for this one. Draw it together and answer the question. When you draw it together, you might be answering the question at the same time. And that's absolutely fine. I love it. You guys are, this is fantastic. You're on the right track. Excellent. Loving your answers. And it will feel like you are doing, you'll feel like you're doing this and you're repeating yourself, and that's totally fine. Yeah, so Spandan is asking a great question. It says, how would you use an equation that you derived in one of these responses? Would you have to reference the derivation somewhere? Absolutely. Especially if they're asking, for example, they might say, if the height was bigger, if you doubled the height, what would happen to the time to fall? So then I could reference that equation and I could talk about how those two letters, how they affect each other or what that proportion is. So it might be, it's just direct. When one goes up, the other one goes up by the same amount. It might be a square root relationship. So if the height goes up by 16, it might be that the distance, that the time only goes up by the square root of that. It might be an inverse relationship. So as long as you have that equation, you can show that really well. All right, some beautiful, beautiful responses that you guys have put. When dropped from the same height, regardless of distance, the two travels at this and land at the same time. And we just want to make sure that we're talking about they have the same acceleration and the same height, and they both have the same zero initial velocity. And that means that they should fall and have the same time. So just some beautiful responses here. You guys are really working hard on this. I love that. And they will land at the same time with the force of gravity. So this is perfect right here. Beautiful job. Let's go ahead. Here's kind of the answer I have. Same thing that you guys did. And so I'm going to move on to the next one. All right. This one wants us to describe the difference between the motion of object A and object B. One of them is doing something that the other one is not doing. And so give the basic physics. Be careful that you don't answer the question quite yet. On the actual test, if you did here, that would be great, but make sure that you have your basic physics down. So what is the basic physics that you have to know to answer this question? That's kind of what you want to think about. What is the basic physics I need to know in order to answer the question? We know that one of these is moving with a constant velocity and the other one has a changing velocity, but that's not basic physics. The basic physics would be which one is which. So which line is constant velocity, which one is changing velocity, and how do you know? So remember, we're just, oh, beautiful. There we go. Now we're getting basic physics. Nice job. There is one paragraph length formation question on the AP exam. It is worth 7 points. And usually it'll have 2 points that are related to you calculating something or just giving some sort of basic physics answer to that. A lot of times they have you calculate something. So on this one, they might have said the object travels 5 meters. What is the average speed of the object? And so you could do that regardless of the path, not the speed, but what is the average velocity of the object? So even though this one took a longer path than this one, they both started and ended at the same spot. So they could ask you first, what is the average velocity of the object regardless of the path? So then you would do that. They'd probably give you 2 points. And then they would say in a clear, coherent paragraph length response, explain in detail the difference in the motion of object A and object B. So that's where you would get 5 points. So we would kind of see that. What I've seen a lot of you do so far is you're telling me the slope of this position time graph gives a velocity. So we know a linear graph gets constant velocity and the curve graph has a velocity that's slowing down. That is great, 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 great basic physics. They've also maybe added a little evidence in this one, which is absolutely fine. Another person said from a position time graph, the slope will represent velocity. Just another one really good, excellent way of talking about basic physics. I said the same thing. The slope of a position versus time graph indicates the velocity or the change of velocity of an object. So that's really our basic physics. Now, cite evidence. How do you know that there is a difference between A and B? So how do you know, looking at the graph, there's a difference in the motion of A and B? You don't need to tell what it is. You just have to tell how you know. So the cite evidence, how do you know that the motion of A and B are different? How do you know that they are different? And it can be super simple. It does not have to be anything else. So I love what Caroline did here. I'm going to show you what Caroline did. She said the slope of B is linear while the slope of A is curved. So she's really saying that the path of A is curved. And then she gives us a little bit more. And then this is really what we are looking for when we draw it together. So here's our evidence, okay? And then here we would say that the slope of A, instead of is curved, Caroline, you might change this to A is changing. The slope of A is changing. And then she gives really a great explanation of the drawing it together. So she did that already. The way I did this, I just said object A has motion in which a curve with a decreasing slope is shown, and object J has a straight line with a positive slope. So that's really what I want to do, is just tell, what are you seeing here? So what evidence do you have that there is a difference in the motion? So there's my evidence. Now I want you to draw it together. Now I would love for you to draw it together. Once again, you guys are doing fantastic on this. So remember, paragraph length, 7 points, QQT, which might have graphs in it just like this, and you might have to do something very similar to this inside of a qualitative, quantitative translation. So you're really kind of practicing both when you do this. But the QQTs are 12 points. Those are the bigger point ones. Awesome responses. Beautiful job, guys. Beautiful, beautiful. Love it. It's our future people that are going to do something amazing in life. And it all starts here with this AP Physics, because you're learning how to learn and how to communicate. It's some awesome communication here. Beautiful job. I love the pair somebody drew. That was awesome. They erased it, but it was awesome to see. Good. Excellent. Beautiful answers. Oh, I love it. Kritika, that's awesome. I love it. All right, I want to show you an answer, and I want to show you something cool about this answer. So one of the things some teachers do is they will say, if you have a position time graph, put 2 dots above your lines. And here's why. If you see that it's not smiling and not frowning, it has a constant velocity, no acceleration. So this person did that, and that helped them. They say object B has a linear slope of a position time graph showing a constant velocity. The 2 dots make that face look like it's not got any expression. It's just a straight line. And I love the next part, because if you look at letter A, you'll see letter A is frowning. And you know, if something's frowning, it has negative acceleration. On the other hand, object A has a curved path showing a changing velocity and a negative acceleration. So kudos to you. That is 100% something I absolutely love to see. Good job, Kritika. I love it. Beautiful job. All right, lots of other awesome responses here that you guys have been giving. I would love to show them all, but we are almost out of time. Let me show you the answer that I have. Since object A has a motion in which a curve with a decreasing slope, it has a negative acceleration while it moves in the positive direction. And then object B has a straight line with positive slope. Therefore, it is traveling with a positive constant velocity. So 2 things tonight that we really want to make sure you remember. In the QQT and the qualitative quantitative translation, you will feel like you are stating things over and over again. Yes, you will be. Take any graph that you have, make a physics equation that will help you on it. And then in the paragraph length response, remember the three things we want to do. We want to do basic physics, then do cite evidence. Tell us what in the world is this picture showing us? Or what is the equation telling us? Or what is the situation telling us? And then finally, we want to draw it together and answer the question at the same time. So as long as you all do that, you will be rock stars on this test. Hey, please, please, please sign up for Tuesday night. That is May the 4th. In other words, may the 4th be with you. We'll give a lot of Star Wars references, but we're going to do some amazing things that night. We're going to study, study, study. We're going to review. We're going to get you ready. And I think you'll love that. Yes, you will have access to these slides after the presentation. Remember, you can also go to Discord. You and Brianna can have an awesome time continuing this conversation. I'm going to put the link. So we're going to do, today is the 28th, 428, fiveable QQT and paragraph length formation. And I'm going to publish some takeaways. So don't go anywhere. We want to make sure that you get these takeaways. So I'm going to put this link into the chat. So here comes the link in the chat. If you click on that link, what you will see is the following. Yeah. No, sorry, Brianna, that's my fault. There is no Discord tonight. So instead, come on Friday. If you have questions, immediate questions, you can go to Discord and ask those. If you click on the Pear Deck link, you're going to see the same screen that I am showing you here right now. After just a little while, maybe 5 minutes or so, maybe less, you will have a Google Doc come up, and that Google Doc will come up, and it will show you your Google Doc. All right, guys. Hey, awesome job tonight. Thank you so much for coming in, spending a little time trying to get ready for the AP Physics 1 exam. Don't forget about the big Cram finale that we have on Tuesday, and we will get you prepared. All right, talk to everybody later. Thank you so much for showing up. Thank you for Brianna so much for moderating the chat. Absolutely awesome job tonight, guys. All right, talk to